Hey guys, it's Miss Miklos, and in today's lecture we're talking about operations with matrices. And so we kind of already saw a matrix like this in our last lecture, and we talked about that this notation for our entries, A sub 1, 1, A sub 2, 3, basically means A sub row column. So it's telling me exactly where I need to go. And that really wasn't that important in our last lesson, but today it's going to come into play much more frequently. We will also see matrices denoted by an uppercase letter. So we'll either see like the full matrix, or it will say like matrix A or something like that. Two matrices are equal when they have the same exact dimension and all their corresponding entries are equal. Okay, and just a quick reminder that our dimension, once again, we always go row by column. And that's the same order that we go for when we're looking at the entry. So if I'm looking at example 1, since these two are in the same spot, we would say A sub 1, 1 is equal to 2. A sub 2, 1 is equal to negative 3. A sub 1, 2, which means row 1, column 2, is negative 1. And A sub 2, 2 is 0. So that's exactly what these entries would be like, and that should make common sense to us. So we can kind of see here, these two matrices are equal to each other because they have the same dimensions and all their corresponding entries are equal, but these are not equal to each other. The reason being, okay, this is a 3 by 2 matrix because it has 3 rows and 2 columns, and this is a 2 by 2. In order to be equivalent, they need to have the same exact dimensions. Adding matrices together, we can add any two matrices, and the key thing is of the same dimension by adding their corresponding entries. If they don't have the same dimension, we can't do anything about it. So for number 2, for part A, negative 1 plus 1 is 0. 0 plus negative 1 is negative 1. 2 plus 3 is 5. 1 plus 2 is 3. And it really is as straightforward as that. In our next one, 1 plus 0 is 1. 0 plus negative 3 is negative 3. 5 plus 2 is 7. 2 plus 4 is 6. Negative 3 plus 0 is negative 3. And 7 plus 1 is 8. Okay, so don't make adding matrices any harder than it needs to be. For C and D, this shows the other way that we will see our notation. So notice it defines matrix A and matrix B, and then it tells me to do A minus B. So I'm going to do 4 minus negative 2. 4 minus negative 2 would be like 4 plus 2, which gives us 6. And I want to point out the reason why I can combine these two is because this is a 3 by 1 matrix, and this is also a 3 by 1 matrix. Negative 6 minus 3 would be negative 9. 0 minus 1 would give us negative 1. Okay, for D, if we're looking at this, here I have a 2 by 3. Here I have a 2 by 2. Those are not the same dimensions, so I'm going to say that there's no solution. I cannot do anything with this because I can only add or subtract matrices that have the same exact dimensions. Okay, scalar multiplication. We kind of talked about scalar multiplication in our last chapter. Scalar just means that I'm multiplying a matrix by a constant. If I'm multiplying by a constant, all I'm going to do is distribute. So 3a tells me I'm doing 3 times, and I'm rewriting out matrix A here. And I'm going to distribute 3 to every single entry in matrix A. So I would get 6, negative 9, 6, 6, 0, 3, 12, negative 3, 6. So hopefully everything so far has kind of been like what you would expect. For B, okay, it tells me to do 2b minus a. So I'm actually going to save us a little bit of time here, and I'm going to distribute the 2 to b kind of in our head. So I would get negative 2, 6, 4, 0, negative 2, 2, 0, 0, 2. And then I'm subtracting 2, negative 3, 2, 2, 0, 1, 4, negative 1, 2. Since these have the same dimensions, they're both 3 by 3s, I could go ahead and subtract our corresponding entries. So negative 2 minus 2 gives me negative 4. 6 minus negative 3 gives me 9. 4 minus 2 gives me 2. 0 minus 2 gives us negative 2. Negative 2 minus 0 is negative 2. 2 minus 1 is 1. 0 minus 4 is negative 4. 0 minus negative 1 is positive 1. 2 minus 2 gives us 0. So once again, we're seeing here that we don't need to make this any more difficult than it looks. Okay, so let's do one more of these. It says a plus 2b. Okay, so this time a, we know, is 2, negative 3, 2, 2, 0, 1, 4, negative 1, 2, plus 2b was negative 2, 6, 4, 0, negative 2, 2, 0, 0, 2. I know I can add these together because they have the same dimensions, so I would get 0, 3, 6, 2, negative 2, 3, 4, negative 1, 4. Okay, so far we've covered how we add matrices together and how we multiply by a scalar value. Okay, we're going to talk about how to multiply matrices together in a little bit, but before we get there, we're going to talk about these properties of matrix addition and scalar multiplication. Our first property says a plus b is the same thing as b plus a. And in that, it's saying that the order can change. So we call that the commutative property of matrix addition. My matrix there is tough to read, but it does say matrix. Okay, so I can add two matrices together. It doesn't matter the order. Okay, number 2, it looks like what's happening here is the groups are changing. So we would call that the associative property of matrix addition. For number 3, it's saying if C and D are both scalar values, so that means that they're numbers, and A is a matrix, I could either do C times D and then multiply that by A, or C times the quantity D times A. So that's saying that the groups are changing, and so that would be the associative property of matrix multiplication. For number 4, it says 1 times A equals A. We learned that when something equals itself, we call that the identity. So number 4 would be scalar identity because it's multiplying a matrix by a value. Number 5, we see that we're getting it's the same thing back again, so we call that the additive identity because this time it was adding. I made one small change here in number 3. I added the term scalar because we'll see that matrix multiplication, we can't always just change the groups around. Okay, so that scalar would be important. For number 6, these both look like we are distributing. So it's just showing that I could either distribute a matrix to 2 scalar values, or I could distribute a scalar value to 2 matrices. And none of these properties are brand new ideas to us. In fact, they're what we're really used to with multiplication and addition. But we can't just assume that everything is the same as what we're used to. So that's why we need to kind of state that those things are true. So we're going to do a few examples and just practice these different properties. So if we look at number 4, it is basically saying 3 times the quantity of these two, the sum of these two matrices. And so there's 2 ways we could do it. We could distribute 3 to this whole matrix and every single entry, and 3 to this whole matrix, but what I think is easier is to add those matrices together first. So I would get 2, 7, negative 2, 8. Then I'm going to multiply everything by 3. So I would get 6, 21, negative 6, 24. So it does not matter which of those 2 ways we do it, we'll get the same answer. I just think that's a lot quicker. Okay, so number 5, I'm going to do the same way. So I would get negative 3, negative 5, 3, 3. When I distribute that, I would get negative 6, negative 10, 6, 6. Okay, so that's kind of the way that we would use some of those properties. Our final concept today is matrix multiplication. And matrix multiplication, unfortunately, is a little bit more work than what we have been doing so far. This is definitely the toughest thing of today. So it says if matrix A is A sub ij, and matrix B is B sub ij, and this is an m by n matrix, and this is an n by p matrix, then the product of AB is an m by p matrix, where the matrix is equal to all this stuff. And if we look at that, and if you guys looked at your book, it seems super confusing. Okay, so let's kind of break it down. First thing we need to know, and I would highlight this somehow, in order to multiply matrices, the number of columns in the first matrix must be equal to the number of rows in the second matrix. Okay, so if we look at number 6, this is a 3 by 2 matrix. This is a 2 by 2 matrix. These numbers right here have to be the same. If those are not the same, then we can't do anything. Our final answer is going to be those dimensions that are on the outside. So our final answer is going to be a 3 by 2. And this is going to be one of those times where I'm really going to be diligent in using the notation for our entries. So I'm going to start here by finding A sub 1, 1. So we know this means row 1, column 1. So what we're going to do is I'm going to multiply row 1 in our first matrix by column 1 in our second matrix. So I'm going to write negative 1 times negative 3 plus 3 times negative 4. So I get I get positive 3 plus negative 4, so I get negative 9. So over here in my answer, I have negative 9. And in fact, I'm going to make this part black, and I'm going to try and color code everything just so we can kind of see where everything's coming from. Okay, next, I'm going to do A sub 2, 1. And it doesn't matter what order we go in, but I know this is row column, so this tells me to take row 2 times column 1. So I'm going to do 4 times negative 3 plus negative 2 times negative 4. So I have negative 12 plus 8, which is negative 4. Notice over here, I'm putting it in row 2, column 1. So that's where that entry would go. Okay, next, A sub 3, 1. That means I'm taking, you guessed it, row 3 times column 1. So I'm going to do 5 times negative 3 plus 0 times negative 4. So I get negative 15. Okay, now off to the side here. I'm going to go ahead and do A sub 1, 2. So this time I'm going to do row 1, column 2 to find this value. So I'm going to use row 1, column 2. So I have negative 1 times 2 plus 3 times 1, which is negative 2 plus 3, so that is 1. Okay, A sub 2, 2 means row 2, column 1. So I have 4 times 2 plus negative 2 times 1. So 8 minus 2 is 6. And lastly here, I need to do A sub 3, 2, which means I'm doing row 3 times column 2. So I would have 5 times 2 plus 0 times 1, which is 10. So this would be our answer. Okay, so we can kind of see it does take a little bit of work. Our math is not difficult, but I would definitely suggest writing this out and taking your time. A lot of times I'll use, like, if I'm using notability, I will circle the two that I am multiplying together, and then I'll erase that. I'll demonstrate that on the next problem. Or if I'm doing this on paper, I might circle and pencil the stuff that I'm multiplying together just to keep me on the right track. Okay, so number 7, first we need to make sure that we can actually multiply this together. So this would be a 2 by 3. So I'm going to say 2 by 3. And this is a 3 by 3. So since these inside numbers are the same, that means that we can do it. And I know that my final answer should be a 2 by 3 because those are our outside numbers. Okay, so should have 2 rows and 3 columns. Okay, so I'm going to find A sub 1, 1. So that is going to be row 1, and let me actually go row 1 and column 1. Okay, so these are the two that I'm going to multiply. So I would get 1 times negative 2 plus 0 times 1 plus 3 times negative 1. So I get negative 2 plus negative 3, which is negative 5. So we can kind of see that even though I'm multiplying 3 numbers together, we're doing the same exact thing. Okay, so now I'm going to do A sub 2, 1. So I'm going to go row 2, column 1. So row 2, column 1. And just for my sake, so I don't get confused, I'm highlighting those. Okay, so multiplying these two, I would get 2 times negative 2 plus negative 1 times 1 plus negative 2 times negative 1. So I would get negative 4 plus negative 1, which is negative 5, plus 2, which would give me negative 3. Now I'm done with this first column, so now I'm going to have to move on to the second column. So I'm going to do A sub, and I didn't mean to write a 2 there. I'm going to do A sub 1, 2. Man, my writing is all over the place here. 1, 2, there we go. So that means row 1 times column 2. So let me go ahead and circle those for us. So I'm going to do 1 times 4 plus 0 times 0 plus 3 times 1. So I get 4 plus 0 plus 3, which is 7. Now I'm going to do A sub 2, 2. So that would mean row 2, column 2. So there's row 2 and column 2. And I have 2 times 4 plus negative 1 times 0 plus negative 2 times 1. So I have 8 plus negative 1 plus negative 2, and that gives me 6. Okay, now we're on to our third and final column. So I'm going to do A sub 1, 3, which means row 1, column 3. So I'm going to once again kind of highlight those for us. So I have 1 times 2 plus 0 times 0 plus 3 times negative 1. So I get 2 plus 0 plus negative 3, so I have negative 1. And last but not least here, I'm going to do A sub 2, 3, which is row 2, column 3. So once again, I'm circling those. So I'm going to do 2 times 2 plus negative 1 times 0 plus negative 2 times negative 1. So I have 4 plus 0 plus 2, so I get 6. So this is my final answer. Notice my final answer does indeed have 2 rows and 3 columns. Now multiplying doesn't get any more difficult than this. It can just take a little bit of time to do. So we're going to practice a few more, just making sure that we are okay. Moving on here to number 8. Okay, I have a 3 by 2 times a 3 by 4. And the thing that stands out to me here is these inside numbers are not the same. So there's no solution. We cannot do anything there because those values do not match. The reason why that becomes important is because I know it's row by column. Notice if I multiplied this first row by this first column, I have this extra 2 there. That causes a problem for me. So our last problem of the day, oh, this one looks nice, doesn't it? Okay, so I have a 3 by 1 times a 1 by 3. These numbers match up, and I know my final answer should be a 3 by 3. Now, the nice thing about this one is that if I'm doing row 1 times column 1, notice I'm just doing 2 numbers times each other. Okay, so I don't really need to write this all out. I'm just going to go kind of do it in my head. Row 1, column 1, 2 times 1 is 2. Row 2, column 1, negative 1 times 1 is negative 1. Row 3, column 1, 1 times 1 is 3. Now moving on, row 1, column 2, I get negative 4. Row 2, column 2, I get positive 2. Row 3, column 2, I get negative 2. Last but not least, row 1, column 3, negative 6. Row 2, column 3, I get 3. And row 3, column 3, I get negative 3. So that would be my final answer. Okay, so with matrix multiplication, we just need to take our time and make sure that we are multiplying correctly.